Hello everyone, my name is Shivam. Um, I'm from the University of Toronto and Brock University. I'm a specialist in artificial intelligence and machine learning, and I work with Google, and I'm currently working in Los Angeles, right? So Today we're going to talk about a very beautiful sequence in mathematics. It's called the Fibonacci sequence, and it's one of the very first programs that I learned to write when I was, learning how to code, right? So, what is a sequence, right? A sequence is anything but just a set of numbers written in a specific format, right? So, for example, this first sequence is just the sequence of positive integers. The next sequence is just a set of positive odd integers, and this next sequence is just the set of squares, right? So these are all just sequences, and Fibonacci sequence is also such kind of sequence where every every number is just the sum of the previous two numbers. So all we have to do is initialize the first two numbers, and then every next number you can find from the last two numbers, right? So in essence, it's just a series. It's just a series of taking two numbers, adding it up, and putting it after the comma, and taking the next two numbers and adding it up and putting after the comma. Basically, that's it. Now let's try to write a program using classic if-else statements for the Fibonacci sequence, right? So, as you know that we always have to initialize our first two terms, because without these first two terms, we will not be able to form a Fibonacci sequence. And very important is that we need to have these two base cases. For example, if I let's say if I want to print out the first 10 Fibonacci numbers, right? Then these two conditions won't be true. However, if for example if I enter 0, well, printing 0 Fibonacci numbers makes no sense, and therefore we say please enter a positive integer, right? So or if it's even 1, then you know that all you have to do is print 0, and n1 here is 0, so you just print 0. However, if you want to print more than 1 Fibonacci numbers, then you will come to the else part, right? And let's say, for example, I want to print 4 Fibonacci numbers, right? So what this count does is just a counter that keeps in track of how many, if it has reached our limit of 4 terms, right? So that's what this counter does. So we begin with a while loop, because we don't know what the end is, that therefore we use a while loop, and starting right off we print it with a 0, right? Because we have to print the first Fibonacci number, which is 0, and then we say that the third Fibonacci number is just the sum of the first two, which is 0 and 1. So nth Fibonacci number, which is the third Fibonacci number in this loop, becomes 1. And then you're not done yet, because you also need to keep in track for the next iteration. The values for n1 and n2 will change, because there no longer would be 0 and 1, but now they would be 1 and 1. And therefore you will change the n2 to n1, and you will swap the nth with the n2, and you'll increment the counter. If you don't increment this counter, then it'll be an infinite loop, because it would never end to see this loop will ever end, right? So you have to reinitialize n1 and n2, and then you go back to print the third term. Now you know the second term right now is 1. So you would print 1, and the process continues. You would change the first two terms, the previous two terms back to 1 and 1, and then it becomes 1 and 2, and the sums becomes 3, and you keep reinitializing that way. So there's a reason why I have marked this in a square, and the reason is all of this can be done in just one line. The trick is by using something called as recursion. In next class, we'll probably be talking about how to do Fibonacci sequence with recursion, and it becomes much faster that way. Can anyone tell me how does recursion work and what it exactly is? Well, the answer is just this. As you know, Fibonacci numbers is the sum of the previous two numbers, so this is just what Fibonacci sequence is, right? And we're also going to learn about the golden ratio, which is one of the most beautiful ratios that we have able to decode nature with. And just a fun fact, Fibonacci Day is on, can anyone guess? It's on November 23rd, because November is 11 and the 23rd is, well, just 2-3. Therefore, November 23rd is the day for is the Fibonacci Day. Well, thanks for being here, and good luck.